Hello everyone, myself Vaibhavi and welcome you all to my channel. Today we are going to cover an important and an interesting topic, that is use of gray code in position encoders and robotics. Let's begin. These are the topics that we are going to cover in this upcoming video. First of all, what is gray code? What is a position encoders? Working of encoder disk? Use of logic gates in gray code? Use of flip-flop in encoder? Advantages and application? And last one is conclusion. We will talk about how gray code is used in position encoders. We will see why gray code is better than normal binary, how it works, and where it is used to make machines more accurate and safe. So now we will see what is gray code. Gray code is a binary numbering system where only one bit changes between successive numbers. In gray code, when we move from one number to the next, only one bit changes at a time. This small change helps prevent errors when machine read fast moving parts. Now let's understand how to convert normal binary into gray code. The first gray code bit is same as the first binary bit. After that, each next gray bit is found the XORing the current bit with the previous binary bit. As you can see that there is only the change of one bit at a time. Now let's see that why is it important for robotics and encoders. It ensures precise position sensing by reducing errors during transitions, making it essential for robotics and automations. When robots move, they change position very fast. If we use normal binary, multiple bits might change at once, causing mistakes. Gray code changes only one bit at a time, making it highly reliable for reading positions without errors. This is why it's critical for robotics and automations. Let's see the characteristics of gray code. Gray code is a binary numeral system where two successive values differ in only one bit, minimizing the risk of errors in digital encoders and combinational circuit. In gray code, two consecutive numbers are only different by one bit. These small changes reduce the risk of errors. It makes gray code perfect for digital encoders where precise movement detection is needed. In robotics, encoders help control joint angles, wheel rotation, and arm movements by providing real-time feedback to the system. A position encoder is a sensor that tells us exactly where a moving object is. In robots, encoder help control how much a joint turns, how much a wheel rotates, how far a robotic arm moves. They provide real-time position feedback to the robot's control. As you can see in this diagram that this is the motor raft, this is the encoder disk, this is the optical center, and this is the digital output signal. Let's see the working of encoder disk at logic level. Number first, disk is divided into multiple concentric tracks. Next one is each track has light and dark sections. Optical sensors are placed to read each track individually. And last one is sensor output a gray code pattern based on the detection of light or dark. Inside the encoder, there is a disk that spins. This disk has multiple tracks, like rings, divided into the light and dark sections. Each track is read by sensor. Light and dark sections represent zeros and ones. When the disk spins, the sensor reads the pattern and produce a gray code output to know the exact position. Look at this diagram. This is a point to the tracks and explain how the sensors are placed at each track. As the disk rotates, sensor detect light or dark section and send electrical signal that is in zeros or one. This signal together form a gray code representing the position. These are the sensors and this is the encoder disk that rotates. Let's see how the flip-flop is used in encoder system. Flip-flop store binary outputs from sensor, holds data from gray code disk reliably, ensures stable and synchronized position data, and commonly use D flip-flop for capturing sensor states. Flip-flop act like memory units. They store the sensor outputs so that the system can read them reliably. D flip-flop are commonly used because they easily capture and hold the sensor data at each moment. This ensures that even fast movements are captured properly without glitches. Now, let's see the safety in automation. Prevents misread signals. Gray code changes only one bit at a time, reducing decoding errors during transitions. Critical for safety critical systems. Ensures reliable position feedback, vital for healthcare robots, industrial arms, and automated vehicles. Gray code improves safety by preventing misreads. Since only one bit changes at a time, the chance of an error during movement is very low. This is very important in robots used in hospital, factories, or self-driving vehicles where safety is critical. Let's see the applications of gray code. Number first is encoder. Look at this diagram. Here we can see how gray code is applied inside different machines. It is used wherever accurate position tracking is needed, like in motors, arms, and AGVs. So these are the application. Number first one is encoders. Accurate position sensing in motors and machinery. Second, robotic arms. Precise joint angle detection. Third, AGVs, reliable wheel tracking for navigation. And last one is automation, used in sensor for feedback and control. Encoders, that is for motor positioning sensing. Robotic arm is for precise movement control. AGVs, that is automated guided vehicles for tracking wheel rotation. And last one is industrial automation for accurate sensors in manufacturing and robots. Now, let's see the industrial robots application. Number first one is automotive manufacturing. Second, assembly line robots. And third one is high speed accuracy. So let's go with the advantages of gray code. Number first one is high accuracy. Gray code changes only one bit at a time, reducing the chance of misread during transition. Second, favor errors minimizes glitches in digital systems, especially in mechanical encoders and position sensors. And last one is high accuracy. Integration with logic gates, flip-flops, and counters make implementation more straightforward and efficient. Also, it is very cheap. Now, let's quickly summarize what we have covered in this video. First, what is gray code? A binary sequence where only one bit changes at a time, minimizes transition errors. Second, why it's important. Essential for accurate position sensing in robotics and automation system. Third one is how it works with digital logic. Uses logic gates, flip-flop, and counters to decode and process signals efficiently. Last one is where it is useful. Found in encoder, robotic joints, and automated machines, reliable motor control. Gray code is special binary system. It is important because it reduces error. It works with logic gates, flip-flop to make systems safe and reliable. It is widely used in robotics, automations, and machinery. Let's get the conclusion part that in conclusion, gray code is a core technology behind reliable position detection. By reducing errors and improving the accuracy, it plays a huge role in making modern robots and machines safe, fast, and precise. These are the references: Introduction to Robotics by John J. Craig, IEEE papers on encoders, and technical websites. Thank you for listening and feel free to ask if you have any questions or doubt. I am happy to explain further. If you like this video, then please like, share and subscribe to my YouTube channel.